Okay, hello everybody. This is the last lecture of hydraulics, and we are on week 2, week 10. And today we are going to discuss the last topic, and then the hydraulic section will be over. And starting from the next week, we will continue with hydrology. So, as you remember that at the beginning of this week, in lecture 1, I introduced you hydraulic jump. And also we just started the lab sessions. I was also there in the first and the second sessions, which was held on Wednesday. So I'm not sure if is there any student who attended the first session. What is your experience, guys? Could you please?
It was easy.
Omrit, you were there?
Yeah, it was easy. Not very difficult lab.
It was not difficult, but I think it is a kind of extra information which provides a kind of practical information, right? So
yeah, it was interesting to see and see how to use the equipment to measure.
Yeah, actually, we didn't aim to design a kind of something difficult for you. The aim of those sessions is to just show you in real life how open channel flow is behaving. Okay, so it is just a kind of extra information or just extra knowledge. In-person knowledge. I want you to gain to learn the topics. Even the reports are not going to be difficult. We simplified it because the thing is that it is the end of semester and we are squeezing the lab session only for 4 weeks. So it is also there is pandemic over there. We cannot put all the students in the same classroom. In the same lab. So this is the design for this year. I hope you found it interesting and somehow informative. It is the whole idea. And the last part of the experiment is about the hydraulic jump. I think you know how to calculate it. Actually, you are going to use this equation, okay? And you will do exactly the same calculation. And you will just show us that in your report, if the observations are matching with the theoretical equations. Okay. If you have any issue in terms of labs, just communicate with me. Communicate with your TA and CC me, okay? I will also follow. Okay, guys, now today is the last topic, as I told you that. And then today we are going to talk about underflow gates. And if we are talking about underflow gates, it is sluice gate. And I think you should remember that even in the experiment setup, there is one sluice gate at the right side of the flume, okay? It is a kind of gate, water is passing under it, okay? It is that type of flume, sluice gates are called underflow gates. And if you have underflow gates, you may have two types of flows. The first one is free flow. You see that how it is forming on the right side, up figure. Okay, this is a free flow. It means that water is passing under the sluice gate and it continues to flow as it is. And there is no hydraulic jump formation over here, okay? So this is called free flow. But if water is having a kind of fluctuations here and rising up like a kind of experiencing a hydraulic jump and continues to flow, this is called drowned outflow, okay? Actually, in engineering structures like sluice gates, in the real life, this zone is also called drowning zone. There will be always some signs next to such buildings showing that this drowning zone never swim or jump in that area. So think in that way, this is a kind of large structure. You can able to jump here, okay? So it is as high as like 3 meters, okay, Y2. And if you jump over there, you cannot escape. I mean, there is no force. I mean, there is no person in the world, even you could be the world-winning professional swimmer, you cannot escape from this drowning zone, and most probably you are going to drown and you will die, okay? So this is very risky place because there is high fluctuations and it makes a kind of always turbulence, and that's why that kind of flow is classified as drowned outflow, and this kind of flow is called as the free outflow. So simply what's happening here, let's have a look at that. This is our specific energy diagram. and this is the original position of the water flow on the left side. I'm in the upstream flow. Okay, this is y1, and this is the total energy what you have. And if there is no friction in the gate, you are going to just have experience that subcritical flow will turn into supercritical flow. Okay, so this is a kind of flow changing equipment, and then you will end up with position 2A. But in real life, if you are talking about a sluice gate, there will be energy loss. Means that you are going to end up with 2B. But if this is a drowned outflow, okay, if this is a drowned outflow, it is just going to happen a kind of hydraulic jump after the gate, even if it starts under the gate, okay, then it is going to jump up. And of course, in every hydraulic jump, it is not it doesn't matter if it is friction, there is friction or not. Every hydraulic jump dissipates some energy, and you are going to lose some energy, and then flow will turn into, again, subcritical flow. Have a look at that. Subcritical flow will turn into subcritical flow. However, you are going to lose a certain amount of energy because of the hydraulic jump occurring after the gate. And if this is not a kind of drowned outflow, you are going to have subcritical flow, which turn into supercritical flow. This is the basic structure of sluice gates. And as I told you that there are two possible flows after the, after the sluice gate, free flow or a drowned outflow. Let's have a look at that, how you can find. And you may remember in the earlier parts of the lecture, and even in fluid mechanics course, and if you are talking about sluice gate, I remember that I explained these topics in fluid mechanics and even in the earlier part of this lecture. This is the coefficient for sluice gates, okay? So there's a coefficient for the sluice gates, and the velocity is not going to be equal just directly to that part. You have to multiply it with a kind of coefficient, okay? It is called discharge coefficient for sluice gates. And one more thing to add, and this sluice gate coefficient is different for free outflow and drowned outflow. And this is one of the best model which tells us that how you can estimate the discharge coefficient. Okay, so also please note that the discharge coefficient is typically ranging between 0.5 and 0.6. It means that you are going to lose almost half of the energy, okay, after a sluice gate. And have a look at that, how you can find. The first thing is that you should calculate Y1, I mean upstream water depth over A. A is the height of the opening, okay? Look at here. A is the height of the opening. It could be any value, and you are going to calculate Y1 over A as a kind of ratio. That's why in this diagram there is no units, okay? If, for example, the ratio is 4, but it could be, for example, the height of the depth, water depth could be 4 meters, A could be 1 meter. It means that Y over A is equal to 4, okay? If it is 4, then you will follow, you will go up, okay? You will go up and hit it for free outflow. For free outflow, the value is something like 0.54, okay, 0.54. Okay, you will go up. But if it is not free fall, free outflow, if it is drowned outflow, then you will follow this one. And also you are going to calculate, you are going to calculate Y2 over A value, Y2 over A value. After calculating the Y2 over A value, you are going to find it. And I think you just realized that Y2 over A value is going to be smaller than Y1 over A value. So if it is, for example, 3, then you are going to hit that diagram right here. Okay, that diagram right here. Go up, hit it, and go left. This is going to be 0.4. I think you understood how to use it. So basically what you will do, again, I'm going to use the, just give me 1 second. I am going to use the annotation bar if I can. Yes, it is here. Okay, so for example, if it is 4, and for a free flow, you will go and hit the dark line on the top. It is for free flow, and then you will make a kind of reading on the left side. This is how you will find CD, coefficient of discharge for a fluid, for a sluice gate. And if it is a drawn flow, you should also calculate the Y2 over A value. Let's assume that it is this, okay? So let's assume that it is this. See that they hit each other here, okay? So I am following this graph, and this will be your value, CD value for a drawn fluid flow, which has, like, for example, 4 meter depth of water in the upstream, 3 meter water depth in the downstream, and 1 meter opening under the gate. And if this is drowned flow, this is what you will get. Okay, so you will see that you will almost lose a certain amount of energy, like sorry, velocity, like you should multiply the value with 0.4. Okay, guys, do you have any question? This is the theoretical part. I will explain you, and then now I'm going to solve one problem, then hydraulic section will be over. Okay, let's solve the problem and keep processing. Okay. It is another simulation for you guys. It shows that if it is 10, y over 1, it goes like this. And if it is 6, y 2 over a, and you are going to hit this and you will go left. It is, I think you just realized that it's almost the same thing I just presented you with the annotation tool. And this is something else I prepared for you to show an alternative solution for an alternative case. Okay, so the problem is that, let's have a look at what it tells us. We have a sluice gate here, and the depth of the water on the upstream is 1.8 meters, and the opening under the gate is 30 centimeters, and we have free outflow. Okay, so you should be careful that if it is given as free outflow or drowned outflow. Okay, there are two differences, two different type of outflows for sluice gates. And determine the flow rate per unit width. It means that, okay, also I realized in your exam that some students are not careful readers. Okay, please read everything carefully in the question. And here it says that per unit width, it means that your width value, what does it mean, width value? And look at that, it is B here, okay? Your width value is 1 meter, okay? Because problem is saying that per unit width. It means that you are going to make the calculations only for 1 meter width. Is it clear? And so the question is that, determine the flow depth and the velocity in the downstream. So you will calculate velocity and flow rate and the depth here. Okay, so it is quite simple. Let's continue with the solution. You are going to use this chart, and the first thing is to calculate the y1 over 2, y1 over a value, because it is free outflow. Okay, so you will not make any calculations for y2 over a value because it is not round outflow. So when you calculate it, you will find it is 6, and you will follow the 6. You will find 6 on the y-axis, and you will go up, down, up, right, and go left. And you should read what is given here. It is, my reading is that 0.57. So this is the coefficient for the sluice gate. And the equation for the sluice gate is given as this. And if you put everything together in the equation, you will find that Q value will be equal to 1.02 cubic meter per second. Okay. And the second thing is that you should calculate the depth. Okay. Here we don't know what is Y2. In order to calculate the depth value, you will use the specific energy equations, and specific energy in the upstream flow is equal to specific energy in the downstream flow. And when you calculate the specific energy, you will see that it is going to be 8.2 meters. Okay. And you are going to use the same equation to calculate the alternative depth on the right side, it is actually what you know very well, and even you got a kind of similar problem in the midterm. And it is interesting that there were only one student, she couldn't solve this problem, but the rest of the classroom solved it correctly. It means that you do have high level of understanding, good level of understanding of the alternative depths, and even it is a topic for the lab experiment. And then you can find that the alternative depth is 0.18 meters, 18 centimeters. And if you calculate the velocity, you will see that this is the velocity value. Okay, guys. So this is the end of hydraulics section. And if you like to ask any questions, please feel free to talk. And now I am closing the hydraulic section. And starting from next week, I will continue with hydrology. Okay, it is the next. It is the second topic in this course. And in most of the universities in teaching civil engineering programs, hydraulics and hydrology are different courses, but somehow we combine them because of the limitations of our program. And I am going to provide you very introductory information and the most critical information about hydrology starting from the next week. I think we will wrap it up in 3 weeks period, and then everything will be done. Okay. Any questions, please?
May I ask about if it was covered before? On the final exam, we will have only hydrology or both hydraulics and hydrology?
Everything
from the first week. Okay.
Everything, Tom, starting from the beginning.
Okay, thank you. Will we have any assignment for the hydrology part?
Yes, I am going to give you the third assignment in this week. Actually, I didn't make my mind. I can give to you 2 assignments from hydrology part, but time is not good enough for 2 assignments. Maybe I can give you 1 more assignment in hydraulics, and the last assignment is only for hydrology. I need a little bit time to think about it. Maybe I will decide on today or tomorrow, okay? But you will get a kind of assignment as soon as possible. There will be 3rd assignment, okay? And I will release it as soon as possible. If I decide that I am going to give the 3rd assignment on hydraulics too, okay? But if I decide to give the assignments from hydrology, 2 more assignments, I think I am going to wait for next week. Okay.
And last question.
Yes, please.
For the hydrology part, we will use the same book as before?
Okay, no. Hydraulics, for hydrology, you cannot use the hydraulic books. I mean, Yunus Çengel's book. This is a good question. Actually, we have another book which was listed in the course specification form. And if you open Moodle, okay, if you open Moodle, you will find a kind of 2 books are there. And the second book is for hydrology. I am pretty sure that most of the students are available, I mean, in campus, and you can find some copies in the library. I remember that like 30 copies or something are available in the library. That's why I selected that book. And plus, I'm going to provide you some materials, don't worry, okay, which is going to help you.
All right, thank you.
Okay. So in Yunus Çengel's book, there is nothing about hydrology. Hydrology is totally kind of separate topic. I mean, it's totally out of hydraulics. They are not the same thing. Any questions? No?
No more questions.
Okay, guys. Actually, I see only girls now on the screen. All the boys are turned on their camera. It seems that they are shy. We have shy boys. Oh, thank you, Serikol. You are a savior. The thing is that, guys, I've been teaching you almost for 10 weeks. And also you took another course, fluid mechanics, from me. And yesterday I was in the library. I got a little bit ashamed of not recognizing you. I mean, I saw several faces over there, like 10, 20 students. But unfortunately, I couldn't recognize most of you because of this pandemic, we are not seeing each other. Okay, at least if you turn on your camera while I'm teaching, I can get some familiarity with your faces. So, and if you also interact with me, definitely I will remember you. And this is important. Okay, maybe you are not realizing that how important it is to be recognized by the professors. When you finish this course, this university, this program, you are going to go maybe for a master degree, and you will ask for us to write letters. And if I don't write letters if I don't remember the faces, because this is a kind of impression in my mind. Okay, I don't remember this girl. I don't remember this boy. Most probably he was not active and was not a good student. So I am just omitting such kind of requests. And by the way, I gave several letters, like maybe 150 letters during last couple of years, 5 years, and more than 90% of those students, they got accepted in the top universities. So what I'm trying to say, that is just a kind of simple example. Just try to involve in the lectures. This is my advice from not only from a professor, from a kind of other people having experience in university teaching. Turn on your camera, be actively engaged in the discussions. For example, now I've been talking with Tomiris. Most probably I'm going to remember her face next time when I saw. Even I will remember her name because she's talking to me, she's asking questions, interacting in the classroom. And when the time comes to end of the year, for example, asking for extra points for an upper grade, trust me, she will get some, but you will not if you are not talking or not turning on your camera. These are some quick tricks for you. Be active, don't be shy, okay? This is online, but it doesn't mean that you should be separated from the teachings. Just actively engage and try to develop some familiarities, okay? This is important, guys. Anyway, it is a little bit maybe late to discuss such things, but we have still time to get to know each other. Okay, so I think it is over for this week, and I will be continue on talking on the next topic, hydrology. It is also interesting topic. I like hydrology.